Hey, this is a quick overview of the address standardizer, how it works, and what you can expect from it, how you can customize it. First, there's two Python scripts that you'll run. One's a server that just, once you run it, it just waits for the request. And the second one is the file that you update with your Excel file name and the column that you want to standardize. And then once you run it, it sends all the addresses to the server to be processed. The server expects this standard addresses file, which is the gold standard. This is what's compared against. For us, I extracted the address column from the DeSoto County point address file and just made it in this one column. All those addresses are very standardized. So this is what I call the gold standard and to match against. And then I can eventually join this back almost like a geocode. The second file is the addresses to clean, and that can be in any more or less any format. You can have as many columns as you need. But when you customize the run standardization file, you'll update that file name and the column name on the file you need to process and the column that you want to be processed. It will generate this output file called standardized addresses, and it'll add the standardized address, the matched address, and the confidence score of the match to the standardized. The standardized address is this address cleaned up. So you can see it capitalized Village Parkway and it condensed Parkway into PKWY. The matched address is actually the result, the recommended address that it matched from the standard address file. So you see this Goodman Road Building 3, it recommended you match to this one with a 75 confidence score. And then you can use this to match, to basically join up to the point address file. Jumping over to the code, I'll go through both of these, explain them, and tell you how to get set up. So all of these are in Python. You can run this in VS Code or Python IDE, wherever you need to. This pip install installs any libraries you might not have installed that you need to run this script. Essentially, the server creates a Flask server that waits on port 5000, localhost port 5000, and it waits for any post request. And once it gets it, it starts processing the address that you send it. It starts processing that through this function. I'll go into this in a second. The run standardization script is the main one you need to customize, and you'll want to update this input file to match the file that you want to process, and then you'll update this column name to match the column that you want to process. You can play with the batch size if you want to increase or decrease that. 200 runs at about 9 seconds a piece, 5 to 9 seconds. And once it's done, it creates this output file, which is named up here. So you can change that as well. Back to the server, a couple of things happen at the beginning. So it loads the standardized address file. Then it extracts it groups them basically by the address number at the beginning of the address. And so it creates a dictionary of those groups, and that helps further down to filter. This is what that looks like. For instance, it goes through and it finds any 3709s, creates that as a key in there, and then it adds any addresses with 3709 to that key. Later, that will be used to filter against. So instead of filtering against 100,000 addresses, it'll search for the number, and then it'll only filter against 3 addresses or 1 address or however many there are in that group. This is the mapping. You can update this if you want to. This is how it standardizes. It cleans up the addresses. So where it sees the word drive, it changes that to DR, lane, LN, cove, CV, and so forth. Northwest, east, south to just the one letter. That matches a lot closer to the DeSoto County points address. This isn't perfect. If Meadows is in the middle of an address and it doesn't need to be at the end, it'll still change it. But we run a fuzzy match on this to help clean that up towards the end. So jumping down to the bottom, when it gets the request from the batch, from the standardization, it processes each address in that batch that's sent over one at a time, and it goes through a few steps. So first, if it's already been matched, it's in the cache already, it just returns the actual addresses in the cache, no more processing necessary. If it's not in the cache, it checks to see if it's already matching, if it already matches one-to-one with the files, with the addresses in the standard addresses file. And if it does, it returns confidence 100. If not, it steps through and it cleans that address. So then it renames drive to DR, cove to CV, uppercases everything. Then it runs one more process to check to see if it's in the standard addresses now with the cleaned up addresses. And if so, then it returns, confidence 100 and is done. If it doesn't match any one-to-one after being standardized, it does a few things here to fuzzy match to give you that confidence interval. First, it extracts the number. This is a regex function to extract the number from the address itself. And if there's a number, then it just sets that address number equal to that result. And if there's no number, then it says none. If there's an address number, then it looks through the dictionary on that address number and returns the filtered addresses. So if, for instance, if there's 3266, it finds 3266 as the number, returns these two addresses, and that is now called filtered addresses. If there is no address number from up here, then it just filtered addresses equals the standardized address. So that doesn't, if there's no number, it just returns sometimes you get like intersections and things like that with no number, but just like, state line and Highway 51 intersection. So there's no number in that address. After it goes through that process and gets any sort of address number there, then it returns the best match and the confidence. So this is basically a fuzzy selection. It loops through Magnolia Bloom drive and it loops through there's Magnolia Leaf drive, and it returns whichever one matches closest, and it gives you the confidence of that return right here. And then that is what is put into the Excel spreadsheet. So to jump up to the best match function, go through that real quick. It removes the numbers because I felt like that was giving it a higher confidence because the number would match. So it sort of increases the fuzzy match confidence. So it, in a sense, sanitizes it, removes the numbers from both the filtered addresses and the input address. And then it runs a fuzzy match on just the words in the address. And it returns the best one, whichever one matches the highest, it returns it. And that's it. That's pretty much the process. And once it returns that, then it sends it back here to this standardization script. And once it's done, this script generates these three columns in the Excel file and creates your output file. And again, you can see the result. We have the matched address. Standard address is the cleaned up version. So I'll go down here to some that aren't clean. Yep. So Russum Drive. So it capitalized that and it came back. And then the matched column over here came back with a recommended match and a score of 100. Dandridge Terrace, it cleaned up Terrace to be TER. And this is where it looks for 3680. It found 3680. And Dory Circle is the closest thing that matches Dandridge Terrace at 3680. So it returned a confidence of 52. So essentially, it goes through this process for everyone. It standardizes it. At first, it looks for the match. If it doesn't find it, it standardizes it. Then it looks for a match there and a confidence interval. So I would say this does match. This returned address is the address that is in the standardized address file. So you can use this address to do a join to this shapefile essentially. And then you can more or less get your geocoded, positioning there. So you can join Cumberland Drive on the matched address, any Cumberland Drive there. From this point, to clean this up, this is more manual at this point. Create that a table, usually filter less than 100. And then I'll sort on this. So, these are zeros, and then run through this process however you want to make this, your process to clean that up. So out of that, there's a 300 that the confidence is less than 100. Once you get over 60, it's pretty close. So your Goodman Roads match, Swinney Lakes matches, Lindsay Cove matches, Swinney Lakes matches. So what I did is I made these 100. I would just go down and type 100, and that way then the filter, it leaves out anything less than 100 after I refresh the filter. And that's pretty much it. Let me know if you need any help. I didn't show you how to run this in VS Code. So I'll stop this. So you just run your pip install. That'll install it if you don't have it installed already. Then you can open up this terminal or have another terminal going. And you'll want to run the server. So Python address standardizer server.py, enter. It'll process and run. And it's just sitting there waiting now. It's waiting for any request from wherever. And that would be this run standardization file. Once you're ready to go, you hit Python run standardization and it gets started. You can see up here, I did it. It takes about 10 seconds per batch of 200 to find the address. Oh, I need to close this or it won't output. Some are faster, some are slower. And then at the end of it, it saves it to standardized addresses. And that's it. Let me know if you have any questions.